Hello everyone. I hope you don't mind the small grids. If you do, I will surely take them off later. Today, or right now, I should say, we are going to do the counterpart of Kirchhoff's current law, which happens to be, well, the counterpart of current, which is voltage, and Kirchhoff's voltage law. Wow, my handwriting really sucks. And it's pretty similar to current law, except you don't deal with the nodes, you deal with a mesh or a loop. And I'm going to explain what that is right now. You have these circuit elements, okay, and take me a minute to draw it, but I can explain a little further ahead. You have these circuit elements, and what it's saying is that in a complete loop through any one of these circuits, it all has to add up. Your voltages have to add up to 0. Not your currents, your voltages. Okay? You have these 5 circuit elements, and we have to write these mesh equations for them. Now you have to look at how many meshes we have, alright, or how many loops. And I can tell you right now we have this loop, we have this loop, and we have this loop. And it's not, you don't really use the master loop outside. You can use any loop inside of a circuit when using Kirchhoff's loop laws. But this is Kirchhoff's voltage law, denoted as KVL. So KVL, and they're not too bad to figure out. You just have to define your loops. So what I like to do is label my nodes first. You don't actually have to label your nodes, but I like to. Up here and up here, I'll call it A, and B, and C, and D, and now I can label my loops based on the nodes. So I'm going to do this first loop here, which is this branch, okay? And first I should include some information on each one of these. This has some voltage, I'm going to call it voltage 2. This has some voltage, I'm going to call it voltage 1. Voltage 3, and these aren't supplies. These aren't giving off voltages. Right now I'm symbolizing the voltages that they're using, that they use up. So this is voltage 5, although I'm retarded and I didn't have a 5. And it's good to give them your pluses and minuses. How I'm gonna plus and minus this, I'm gonna think of B as my positive terminal, and from there we know that the right side, or this side of the resistor, has to be the lower potential side because they're both in series. Same thing on this side, and even the same thing in the center. Now we have our voltages and our polarities, our nodes. We're all set up to do this equation, except we have to label our loops. And just find as many loops as you can. So my first loop is going to be A, B, D, which means it's going from A to B to D, and then correspondingly back to A. It's hard to, I guess it would be easier if instead I labeled each turn and I think that would be easier to make the loop, to label the loop. You don't have to, but I'll do it anyhow. So that's the first loop. Our second loop is going to be B, C, F, E. And our third loop is going to be the whole thing, A, C, F, D. Alright, and now that you made that connection, I'm just moving these out of my way. I'll pull them up there, I guess, or I'll stick them down here. Is where I'll stick them. And now we have to write our voltage loop loss for those. So our first loop, I hope you guys can still see the loops. And let me move this down. Keep Kirchhoff's in there. Alright, so the voltages for our first loop. Loop 1. Every time I click black, it wants to stay in red. Loop 1. Alright, now here's the convention for voltage. If you're traveling through the wire and your loop is this way, let's say, and you go from minus to plus, because we're traveling this way, for V5 we would be going from a minus to a plus. We would say that that is when it is a minus. So if we're going from minus to plus, that means that it is not passive. That means that it's not using power, but it's actually giving off power. Remember, these aren't resistors, they're just circuit elements. And because our loop, how we're defining it, because we're going this way around the loop, and we're going from the minus to the plus, we're saying that this is giving off power, which means in our equation, it has to be a negative. Anything that's giving the circuit power is a negative, anything that's taking it away is a positive. And I know that's kind of a weird notation, but that's just how it is. And we say negative V3, which is this one here that I'm underlining, negative V3, and now we just follow the loop. I'll denote it with the arrows. We have that one. Now we do this one, and we're going from a plus to a minus. So now it's passive, so now we add V4. Same thing with this for V5. We're going plus to a minus, so we add V5, and then there's nothing through here, and that all has to equal 0. We have to do that for loop 2. Oh, that was loop 2. What am I doing? Losing my mind. So now we have to do it for loop 1, which is this one, and we'll keep the same direction. Makes things a lot easier to keep the same direction. We're going from minus to plus through V1, so we have to say minus V1. We're going minus to plus for V2, so let's say minus V2. We're going plus to minus for V5, so we're going to have to say plus V5. Oh, not V5, V3, the middle one. And that has to equal 0 as well. And then you want to do the big loop, which is number 3. It's the ACFD, the outer edge here. We have our C, our A, our D, and our F. If you want to trace that loop, that's fine, but do our big loop now, and we'll start with V1. And we're going the same direction as the other ones, which is clockwise. We need a minus V1, a minus V2, a plus V4, a plus V5, and that's it. And that's equal to 0. And Kirchhoff, you can write this in different ways, and one of these meshes may end up being redundant. It doesn't mean that they will be. And depending on what you're looking for in the circuit and how many equations you need is how many meshes that you're going to need to use. If you know V2 and you know V3 and you're looking for V1, you only need one mesh, and you use loop 1. You would use loop 1's equation to solve for that, because you only have one unknown. And it's rule of thumb that if you have one unknown, you need one equation. If you have two unknowns, you need two equations with the same counterpart, with the same parameters. 3 unknowns is 3 equations. Yada yada yada. It goes on forever. That's how many equations you need. So depending on our next video, which is going to be an example of this with real numbers, and then after that video I'm doing a super example that involves both KVL and KCL, Kirchhoff's voltage law and Kirchhoff's current law, and we'll be using some Ohm's law and whatnot like that. But just tune into the next video and check out a live example, or not a live, a real example with some values to that mess of equations there, and we'll see what we can do.